everyone, hope all of you are doing well. Today we are going to start with the NCERT textbook solutions and numericals from the chapter Electricity of grade 10. Are you ready to go with first question? Page number 213. The first question is, draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor, an 8 ohm resistor and 12 ohm resistor and a plug key all connected in series. Here we have to draw the circuit diagram consisting of 3 cells, 3 resistors and a plug key. Okay, and all should be connected in series. Now we can draw the circuit. Here it is given that the 3 cells of the battery are connected in series. So how we can find the potential difference of the battery? That will be the sum of the 3 cells, right? That is V1 plus V2 plus V3. Here we have 2 volt each. So we can calculate the potential difference by adding the 3. That is 2V plus 2V plus 2V. That is equal to 6 volt. We know that this in the case of series connection we have to connect it in end to end. Okay, so that the batteries, whenever we are connecting the battery, each cell should be connected end to end, and we have 3 resistors which are also connected in series. So how we will connect? That also should be connected end to end. That is 5 ohm, 8 ohm and 12 ohm. These 3 should be connected end to end. And one more plug key is also connected in the circuit to make it closed. That means the current is flowing in the circuit. So we can draw the circuit as shown in the diagram. Okay, all should be series. That means all should be connected end to end only. Okay. Now question number 2. Redraw the circuit of question 1. Putting in an ammeter to measure the current through the resistors and a voltmeter to measure potential difference across the 12 ohm resistor. What would be the readings in the ammeter and the voltmeter? Here we have to redraw the circuit by putting ammeter and voltmeter in the circuit in order to measure the potential difference and current across the circuit. How can we calculate the potential difference and current in a circuit? We can use Ohm's law, right? So that we have to connect the ammeter and voltmeter in the circuit, and it is given that the ammeter should be always connected in series with the resistors, and the voltmeter we can connect in parallel only, okay, with the resistors, so that we can connect the circuit as shown in the diagram. Here Ohm's law can be used to find the readings of ammeter and voltmeter, and according to Ohm's law we have V equal to I into R, where V is the potential difference and it is given that V is 6 volt here and current flowing through the circuit is I. So how we can calculate the resistance of the circuit? Here the resistors are connected in series, that is why R will be equal to R1 plus R2 plus R3, that is 5 plus 8 plus 12 ohm, that will be 25 ohm. So that we are getting the I value as I equal to V by R, that is 6 divided by 25, that value is 0.24. Now we got the value of current as 0.24 amperes. Here R1 is 1 ohm and R2 is 10 raised to 6 ohm. We have 1 by R equal to 1 by R1 plus 1 by R2, or we can calculate. Now in order to calculate the potential difference across 12 ohm, we can use Ohm's law again. Okay, so we have V is equal to IR. Here V1 we are calculating because only across 12 ohm we are going to calculate the potential difference. So that V is equal to I into R. Here I value, that means the value of current we have already calculated, that is 0.24, and R is 12. Okay, so that we can find out the potential difference as V1 equal to IR, that will be equal to 0.24 into 12, that is equal to 2.88 volt. Now the ammeter and voltmeter reading is calculated, that is ammeter reading is 0.24 amperes and the voltmeter reading is 2.88 volt. Now we can move to page number 216. The first question is, judge the equivalent resistance when the following are connected in parallel. A. 1 ohm and 10 raised to 6 ohm. B. 1 ohm and 10 raised to 3 ohm and 10 raised to 6 ohm. Okay, here we have to calculate the equivalent resistance in the case of parallel connection. We have studied 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. By using that equation, we can calculate the values, equivalent resistors. R equal to R1 R2 divided by R1 plus R2. When we substitute the values for R1 and R2, we will get R as 1 into 10 raised to 6 divided by 1 plus 10 raised to 6. That will be approximately equal to 10 raised to 6 by 10 raised to 6. That will be 1 ohm. So that the equivalent resistance in the case of parallel connection of 1 ohm and 10 raised to 6 ohm is 1 ohm. Here we have 3 resistors instead of 2 resistors, that is R1 equal to 1 ohm, R2 equal to 10 cube ohm and R3 equal to 10 raised to 6 ohm. So it is also connected in parallel, so that we can use the equation 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. So that we can substitute the values, that is 1 by 1 plus 1 by 10 raised to 3 plus 1 by 10 raised to 6. So when we calculate the values, we are getting the equivalent resistance as 0.999 ohm. Therefore, equivalent resistance equal to 0.999 ohm. Now we can move to the second question. An electric lamp of 100 ohm, a toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much current as all 3 appliances, and what is the current through it? Here it is given that the 3 resistors, that is 100 ohm, 50 ohm and 500 ohm, are connected in parallel to a 220 volt source, and an electric iron is also connected to the same source. We have to calculate the current. Now we can write down the given quantities, that is resistance of electric lamp R1, that is equal to 100 ohm, resistance of toaster R2, that is 50 ohm, resistance of water filter, that is R3, equal to 500 ohm. Now we have the potential difference of the source as V equal to 220 volt. For connecting in parallel the 3 resistors and the source, we have to connect the 4 ends together in one side and the other 4 sides in the other end, as shown in the diagram. Let R be the equivalent resistance of the circuit. Then we can find the value of R by using the equation 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Then substitute the values of R1, R2 and R3. We will get 1 by 100 plus 1 by 50 plus 1 by 500. Taking the LCM, then we will get the value as 5 plus 10 plus 1 by 500. That will be equal to 16 by 500, or R equal to 500 by 16. Now according to Ohm's law, we have V is equal to IR. Now we are getting the value of R as 500 by 16. Then from the Ohm's law, we will get I equal to V by R. Then substituting the value of V and R, we will get I, that is I equal to 220 is the voltage or potential difference, so 220 divided by 500 by 16. So when we are calculating the value, we will get it as 7.04 amperes. Then that is 7.04 ampere of current is drawn by all the 3 given appliances. Therefore, current drawn by an electric iron connected to the same source of potential 220 volt is also 7.04 ampere. Now let R dash be the resistance of an electric iron. Then again from Ohm's law, we will get V is equal to I into R dash. So that we can find R dash as R dash is equal to V by I. So when we substitute the values of V and I, we will get as 220 by 7.04, that is equal to 31.25 ohm. That is the resistance of electric iron. Okay, and the current flowing is 7.04 amperes. So now we can conclude the video here. Hope it is clear to you, and if you like my videos, you please like, share and subscribe. Thanks for watching.